All right, let's get right into it. The term multimodal AI has been around for a while, but what it actually means and what these models can do has totally changed. We're moving way beyond a clunky, bolted-together system into something, well, something much, much smarter.
Think about it like this. You can type a question into an AI, no problem. But what if your issue is visual? Let's say some weird little icon just appeared on your phone's status bar. You don't want to try and describe it, right? You just want to take a screenshot and ask, what on earth is this? That's a whole different ballgame. That needs an AI that gets both your words and your picture at the same time.
And to understand that, we have to talk about a key concept, modality. It sounds technical, but it's super simple. A modality is just the type of data we're talking about. Text is one modality, images are another, audio is a third. Your standard large language model, it's single modality. Text goes in, text comes out. But that phone problem, that requires a multimodal AI, one that can juggle multiple data types all at once.
So how did we first try to crack this problem? Well, the initial method was what I like to call the bolt-on approach. And yeah, it's pretty much exactly what it sounds like. Instead of building one cohesive system, it was more like duct taping two different models together and hoping for the best.
Here's how it would work. First, that image you upload, it doesn't even go to the language model. Nope. It gets sent to a completely separate model, a vision encoder. Its only job is to look at the picture and basically boil it down to a numerical summary, a bunch of numbers. Then, those numbers get passed over to the LLM, which tries to figure out what they mean in the context of your question.
And this quote right here, it hits the nail on the head. This is the critical weakness. The language model never actually sees your screenshot. It only sees that summary. Imagine trying to appreciate a beautiful painting, but instead of seeing it, someone just reads you a list of the colors used. You lose all the nuance, all the important details. That's exactly what was happening here.
So you might be thinking, okay, if this approach is so flawed, why is it still around? And that's a fair question. It really comes down to a few practical things. For one, these systems are often cheaper to run. Plus, because they're modular, you can upgrade the vision part without having to retrain the whole shebang. And for some specific business tasks, honestly, it's good enough.
But good enough is never the end of the story, right? The real breakthrough, the game changer, is a totally new way of thinking, called native multimodality. Instead of bolting models together, this new approach gets all the different kinds of data to live and speak the same language in a single shared universe.
So let me try to explain this shared universe, or what's technically called a vector space. When you give a model the word cat, it doesn't just see 3 letters. It converts that word into a bunch of numbers, a vector, which represents a single point in a massive high-dimensional space. Think of it like a single point on a giant, complex map of concepts.
Now here's where the magic happens. With this native multimodal approach, we can do the exact same thing with images. A picture of a cat gets broken up into little patches, and each patch gets turned into its own point on that very same map. And crucially, that point lands right next to the point for the word cat.
This is the key to everything. Text, images, audio, you name it. They all get embedded together, living in the same conceptual space. There's no need for the model to translate between an image brain and a language brain. It's all just one unified universe of ideas.
So why does this matter so much? Let's go all the way back to our phone screenshot problem. Because the model is thinking about your text and the image at the same time in the same space, it knows exactly where to look. When you ask about that tiny little icon, it can focus its attention right there. No critical detail gets lost in translation.
Okay, so we've covered text and images, but what happens when you add another layer of complexity? What happens when you throw in the dimension of time with something like video?
Well, the old method was pretty clumsy. It would just sample a few still frames from a video and then analyze them like separate pictures. But think about it. If you see one snapshot of a person holding a water bottle, you have no idea if they're picking it up or putting it down. The meaning is in the motion. The new way is way smarter. It uses spatiotemporal patches. You can think of them as little 3D cubes of information, capturing an area over a short period of time. The motion is literally baked right into the data itself.
And all of this, the shared universe for images, text, and even video, it leads to the ultimate payoff. It unlocks a capability that people are calling any-to-any generation. Which, of course, brings us to the most important question of all. What incredible new things can you actually do with this technology? This is the any-to-any promise, and it is wild. You can give the model any combination of data you want, but the truly mind-blowing part is the output. Imagine asking the model, explain how to tie a tie. Sure, it can give you a text-based list of steps, but it can also generate, right on the spot, a brand new short video clip that actually shows you how to do it, a video that was created from scratch just for you.
And the only reason this is even possible, the only reason it all makes sense, is because it's happening in that same shared vector space. The concept of a knot, the word tighten, and the visuals of those actions all exist side by side, allowing the model to move between them and generate stuff seamlessly.
This quote really captures the essence of what this new wave of AI is. It's not just a language model with eyes and ears bolted on. It is, fundamentally, a single model that can see and read and hear and then respond in kind.
So that's where we are today, but it leaves us with a final, really powerful question to think about. What becomes possible when an AI truly has all of our human senses, and maybe even some that we don't?
Thank you. Share and subscribe to Learn AI for more AI insights.